Hi, I'm Miles with the School of Earth Sciences, and today I'm here with
Mary Cirino. Hi, I'm a sophomore at Stanford studying Earth systems, and today I want to talk with you about my summer research on the West Pacific Ocean and how we use coral to demystify the Earth's climate system. Coral is actually a colony of organisms. When they grow, the coral builds up a skeleton over years, decades, and centuries, sort of like tree rings, so the deeper we go, the farther back in time we can measure. By measuring the amounts of certain elements, specifically strontium and calcium, we can figure out how hot the water was when the coral first formed, and see how the temperature has changed over time. By measuring certain kinds of oxygen, yes, there are more than one, we can figure out how salty the water was. This tells us a lot about how much it was raining. Why is this important? Well, the coral I used in my research came from American Samoa, which lies on the edge of the West Pacific Warm Pool, basically a region in the Pacific Ocean where warm water accumulates due to climate circulation patterns. The West Pacific Warm Pool has been called the Earth's heat engine, and the extent of the warm pool has a huge impact on global climate, depending on how the heat is spread out over the Pacific. Interestingly, this heat engine isn't completely stable. From time to time, the warm water expands to the east. We call this an El Niño event. And El Niño is part of a much bigger climate system called El Niño Southern Oscillation, also known as ENSO, which affects climate from Asia to the Pacific Ocean, to the US, to South America, to the Atlantic Ocean, to Africa, everywhere! ENSO can affect droughts, crop prices, hurricanes, and even the spread of diseases. So it's really important to know how this system works. Ideally, we want to know climate conditions like temperature and precipitation at every point on the globe at every time in the past, especially over the oceans. Sadly, this just isn't possible. But we can understand how things have changed through time at any one location, like American Samoa. Put a lot of these locations together and we can start to build a map of how the West Pacific Warm Pool has changed over time. By measuring the strontium, calcium, and oxygen in the coral, my research helped fill a 750-mile hole in that map, and gave us a record reaching back nearly 500 years. As we collect more corals from the Western Pacific, our map of Earth's heat engine will get better and better and help us figure out another piece of the El Niño system puzzle. Essentially, we took something as small as a piece of coral and used it to contribute to a greater picture of ENSO, our climate, and the Earth itself.